that serial number, volume of sodium hydroxide, and here the conductance. Here the conductance. So these are the columns in the table like this. ఈ టేబుల్లో ఈ విధంగా కాలమ్స్ తీసుకోవాలి. Serial number 1 and volume of sodium hydroxide. Initially we are not added sodium hydroxide. Sodium hydroxide first add cheyaddu, so that 0 ml. And note down the conductance of the pure HCl solution. Okay, so for example, the conductance is 100 ohm universe centimeter universe అనుకుందాం. And next ఏం చేయాలంటే నెక్స్ట్ సెకండ్ వన్, add 1 ml of sodium hydroxide solution to the HCl. Add 1 ml of sodium hydroxide solution to the HCl solution. Okay, when the sodium hydroxide is added to the HCl solution, what about the conductance? Conductance, is it increases or decreases? ఇప్పుడు ఏం చేస్తున్నాము, ఇనిషియల్గా ఏం చేసాము, 40 ml of HCl solution conductance తీసుకున్నాము, that is 100 అనుకుంటున్నాం. Let's the conductance of this 40 ml HCl solution is 100 ohm universe centimeter universe. And after that add 1 ml of sodium hydroxide solution to the HCl solution which is present in the beaker. Okay, and note down the conductance of the mixture. Note down the conductance of the mixture. So here we added 1 ml. So the mixture conductance will be decreases or increases? Decrease avutunda, increase avutunda? The conductance will be decreases. For example, 90 vachinandi. So gradually by adding sodium hydroxide, the conductance will be decreases. By adding sodium hydroxide, gradually the conductance will be decreases. Okay, and let's add another 1 ml, so that is 2 ml. Okay, and the conductance again decreases, for example 80. Okay, so like that, by adding sodium hydroxide solution, the conductance will be decreases until the total reaction will be completed. Okay, so ekkada varaku decrease avutu vastundi, reaction complete aye varaku vastundi. For example, at 10th ml the conductance is suppose 20 anukundam. At 10th ml the conductance gradually decreases to 20. At 10th ml the conductance gradually decreases to 20 anukundam. Whenever add 11th ml, again the conductance starts to increase. For example, the conductance is 30, and again 12th ml is added, the conductance increases to 35. Like that, now the conductance starts increase avukuntu veltundi. See, up to certain volume the conductance will be decreases. After that the conductance starts increases. After that the conductance starts increases. So observe the conductance values, and by that we can determine the end point. So where we take the end point, where the conductance starts increases, there we have to take the end point. Where at what ml, at what volume the conductance increases, at what volume the conductance starts to increases, ekkada start avutundi, ekkada increase avutundi. See here, from starting to 10th ml the conductance decreases, and by adding 11th ml the conductance starts to increases. అర్థం అవుతుందా? 10th ml దాకా డిక్రీజ్ అయింది కదా, మళ్ళీ 11th ml యాడ్ చేయగానే ఏమవుతుంది, ఇంక్రీజ్ అవ్వడం స్టార్ట్ అవుతుంది. సో హియర్ అబ్జర్వ్ ద కండక్టెన్స్ వాల్యూస్, వేర్ ద కండక్టెన్స్ స్టార్ట్స్ ఇంక్రీజెస్, దేర్ టేక్ ఏ ఎండ్ పాయింట్. సో ఎక్కడ ఇంక్రీజ్ అవుతుంది, at 11th ml conductance starts to increases. కాబట్టి you take 10 ml as the end point. So 10 ml is the end point. So 10 ml is enough to neutralize the HCl solution. So 10 ml of sodium hydroxide is enough to neutralize the HCl solution. So that can be, ఎలా తెలిసింది నీకు, that can be known by the conductance values. ఓకే, ఇక్కడ ఎండ్ పాయింట్ ఎలా వచ్చింది, ఎండ్ పాయింట్ అంటే ఎలా మనం డిటర్మైన్ చేసాం. సో గ్రాడ్యువల్లీ ద కండక్టెన్స్ వాల్యూస్ ఆర్ డిక్రీజ్ అవ్వకుంటూ వస్తాయి. ఎందుకు డిక్రీజ్ అవుతాయి? వై ద కండక్టెన్స్ వాల్యూస్ ఆర్ డిక్రీజెస్? See, initially the conductance of HCl solution is due to H plus ions, is due to number of H plus ions. Okay, and to this we are adding the sodium hydroxide solution. ఏం చేస్తున్నాం మనం ఇక్కడ sodium hydroxide solution యాడ్ చేస్తున్నాం. By adding sodium hydroxide solution, what happened? This OH minus ion, this OH minus ion reacts with the H plus ion, reacts with the H plus ion and form the water molecule. By adding NaOH, what happened? The number of H plus ions are gradually decreases. Sodium hydroxide solution అంతే కదా, OH minus ions యాడ్ చేయడం ద్వారా ఏమవుతున్నాయి? H plus ions decrease అవుతున్నాయి. If the H plus ions are decreases, what about conductance values? Also decreases to certain volume. Okay, అంటే ఎప్పటి వరకు డిక్రీజ్ అవ్వకుండా వస్తాయి? Until the total H plus ions are completed in the HCl. HCl లో ఉండే టోటల్ H plus ions అయిపోయేంత వరకు కూడా కండక్టెన్స్ వాల్యూస్ డిక్రీజ్ అవ్వకుండానే వస్తాయి. ఓకేనా? సో ఆఫ్టర్ కంప్లీషన్ ఆఫ్ H plus ions, సో ఎక్కడ ఎన్ని ఎంఎల్ దాకా ఎక్కడి వరకు డిక్రీజ్ అవ్వకుండా వచ్చాయి? 10 ml వరకు డిక్రీజ్ అవ్వకుండా వచ్చాయి. అంటే ఏంటి? టోటల్ H plus ions ఇక్కడ అయిపోయినట్టే కదా. And so total H plus ions are completed at 10 ml of the NaOH solution. And what it indicates? There the total reaction is completed, so that the 10 ml is taken as a end point. 10 ml ను end point గా తీసుకోవాలి. అది ఎప్పుడు తెలిసింది మీకు? 10 ml is enough to neutralize the HCl solution అని ఎప్పుడు తెలిసింది? By adding 11th ml. 11th ml యాడ్ చేయగానే తెలిసింది. ఎలా తెలిసింది? Now the conductance values are starts to increases. Okay, increase అవడం స్టార్ట్ అవుతుంది కాబట్టి, సో increase అవడం స్టార్ట్ అవుతుంది కాబట్టి, సో 10 ml is enough to neutralize the HCl solution అని తెలుస్తుంది. ఎందుకు ఇంక్రీజ్ అవుతుంది మరి? 11th ml యాడ్ చేయగానే కండక్టెన్స్ వాల్యూస్ ఎందుకు ఇంక్రీజ్ అవుతాయి? సో 11th ml అంటే మళ్ళీ NaOH ని యాడ్ చేస్తున్నాం కదా. NaOH ని యాడ్ చేస్తున్నాం అంటే OH minus ions are added. If OH minus ions are added, the conductance starts to increase. So if OH minus 11th ml, 12th ml, 13th ml, 14th ml అట్లా యాడ్ చేసుకుంటూనే వెళ్తున్నాం. యాడ్ చేసుకుంటూ వెళ్తే ఏమవుతుంది? Number of OH minus ions are increases. If number of OH minus ions are increases, the conductance also increases. So conductance అనేది కూడా ఇంక్రీజ్ అవ్వకుంటూ వెళ్తుంది. So this volume is taken as a end point. So like that we can determine the end point by the conductance values and draw the graph. So the graph is between conductance values and volume of sodium hydroxide. Okay, so ఎలా డ్రా చేయాలి? Between the conductance and end point by the draw the graph. Conductance on y-axis, and volume of sodium hydroxide and x-axis. So initially the volume of sodium hydroxide is 0. So volume of sodium hydroxide is 0. At 0 ml, what is the conductance? Maximum. At 0 ml, what is the conductance? Maximum. And by adding sodium hydroxide, the conductance gradually decreases to certain volume. And then starts the conductance and ఏమవుతుంది? మళ్ళీ కండక్టెన్స్ అనేది ఇంక్రీజ్ అవ్వకుంటూ వెళ్తుంది. ఇలా వస్తుంది. సో the shape of the curve is V shape. ఎలా వస్తుంది? V shape లో వస్తుంది. So this indicates what? This indicates the end point. ఇదేమి ఇండికేట్ చేస్తుంది? ఎండ్ పాయింట్ ని ఇండికేట్ చేస్తుంది. So this point indicates end point. At this point, this is the volume, and at this point, this is the conductance. Okay, so like that we can draw the graph of conductometric titrations. Okay, so this is about the conductometric titration. Okay, is it clear? సింపుల్ ఏంటంటే ఎండ్ పాయింట్ ఎలా ఫైండ్ అవుట్ చేయాలి? ఎండ్ పాయింట్ ఎలా ఫైండ్ అవుట్ చేస్తున్నాం? by the conductance values, by observing the conductance values. So like that we can ఎక్కడ అబ్జర్వ్ చేశారు కండక్టెన్స్ వాల్యూస్? ఎక్కడ ఎండ్ పాయింట్ గా అబ్జర్వ్ చేశారు? Okay, end point can be determined where the conductance values increases. So gradually the conductance values are decreases at certain volume. the conductance value starts to increases. Okay, starts to increases. So at that point, we consider as a end point. ఆ పాయింట్ మనం ఎండ్ పాయింట్ గా తీసుకుంటున్నాం. సో దిస్ ఇస్ అబౌట్ ది conductometric titration. And next, gradually the conductance value. Similarly, potentiometric titrations. Potentiometric titrations increases. Okay, starts to increases. So at that point, we consider as a potentiometric titrations. Into point ga తీసుకుంటాం. So this is about the conductometric titration. And next, similarly, potentiometric titrations. Potentiometric titration. Potentiometric titration. So what is potentiometric titration? Same conductometric titrations లాగానే potentiometric titrations. So it is a titration. It is a titration in which it is a titration in which end point end point can be determined by it is a potential values by potential values. It is a titration determined by in which end point potential values can be okay. So here the end point can be determined by the potential values. Potential values base చేసుకొని end point ను determine చేస్తాం కాబట్టి it is known as potentiometric titration. In previous case, by the conductance values, that conductance values end point can be determined, so that the type of titration is known as conductometric titration. And here it is here the end point can be determined by the potential values kabatti, so it is known as potentiometric titration. Potentiometric titration. And here also so many titrations are there: acid base titrations, potentiometric titrations, redox titrations. In our syllabus we have redox titrations. Redox titrations by the potential values kabatti, so redox titrations. So for this we take the example and iron solution, Fe+2 solution, Fe+2 solution versus potassium dichromate solution, K2Cr2O7 solution, potassium dichromate solution. Okay, so in the redox titration we are taking the Fe+2 solution and potassium dichromate solution. Same ఇంత ముందు లాగానే చేయాలి. Okay, so take the Fe+2 solution in a small beaker. Fe+2 solution in a small beaker. Okay, so in the redox titration we are taking okay. And next solution, and in this solution keep the two electrodes. One is working electrode and another one is the reference electrode. And these two electrodes were connected to a device which measures the EMF. Okay, so these two electrodes are connected to a device which measures what? EMF. EMF nu measure చేస్తుంది. EMF is nothing but potential of the two electrodes. మనం చెప్పుకున్నాం కదా, potential of the two electrodes is known as EMF or E cell. So here when these two electrodes are immersed in the Fe+2 solution, and these two electrodes measures the EMF of this solution, and it is displayed on this device. So the device is known as potentiometer. దీన్ని ఏమంటాం? Potentiometer అంటాం. Okay, so in this one is what? Working electrode. So దీన్నే working electrode అంటాం. Working electrode of the solution. Working electrode. And this is what? A reference electrode. Reference electrode. Reference electrode. Okay, so this is working electrode and that is reference electrode. So here we keep the two electrodes in the solution and which are connected to the potentiometer, which measures the EMF of this solution. And note down the EMF of the solution, and note down the EMF of the solution, and then take the burette and fix with the burette stand, and fill the burette with potassium dichromate solution. Potassium dichromate solution. Okay, add potassium dichromate solution to the Fe plus 2 solution gradually. And what happened? The conductance, the EMF of the solution increases. ఇక్కడ ఏమవుతుంది? Increase అవుతుంది. So here the table is like this: serial number and volume of K2Cr2O7, K2Cr2O7, and here EMF. EMF. Okay. So ఇక్కడ ఏం చేయాలి? 0 ml and note down the EMF. Initial EMF is for example 300 volts అనుకుందాం. 300 volts. By adding potassium dichromate, the EMF values are gradually decreases. For example 290. Like that, the EMF values are increases. EMF is for example 300 volts అనుకుందాం. 300 volts. By adding potassium dichromate, so here the EMF values are gradually starts to increases. ఏమవుతాయి? Increase అవుతాయి. For example 320, like that, 340. Okay, so like that the EMF values are increases up to certain volume. For example 10 ml వరకు increase అవ్వకుంటూ వచ్చిన. For example at this 400 volts అనుకుందాం. 400 volts at 11th ml and at 11th ml and at 11th ml, see the EMF values are constantly at 11th ml the EMF values are constant, means 401, like that, 402. So gradually slowly increases. So totally the EMF values are totally increases. మొత్తం increases. But at a particular volume the EMF value is suddenly increases. For example, so here it is 600 అనుకుందాం. 401. So gradually the EMF values are increases. At particular volume the EMF value is suddenly increases. And then the EMF values are increases but constantly increase అవుతాయి. Okay, so where the EMF value is suddenly increases, there we take the end point. ఎక్కడైతే EMF value sudden increase అవుతుందో, there we are taking the end point. For example, at 10th ml the EMF is 600. For example, what is the difference between these two value? 20, like that. But here, so before the at 9th ml, if the EMF value is 400, and at 10th ml the EMF value is 600. Here what happened? The EMF values are suddenly increases. So at this volume the EMF value suddenly increases, so that it is considered as a end point volume. So like that, so we can take the end point by the potential values. Okay, by the potential values, and substitute that value in so M1 V1 is equal to M2 V2. M1 V1 by N1 is equal to M2 V2 by N2. So ఈ ఫార్ములాలో సబ్స్టిట్యూట్ చేస్తే we get the concentration of the unknown solution. Okay, we get the concentration of the unknown solution. Okay, so here N1 తీసుకోవాలి. N1 and N2. What is N1 and N2? Number of moles of Fe plus 2 solution, and N2 is number of moles of potassium dichromate solution. So how can you know number of moles? So here Fe plus 2 reacts with Cr2O7 minus 2 in the presence of acidic medium. Gives rise to Fe plus 3 and Cr plus 3 and 7H2O. Okay, so here how many moles of iron? 6 moles. And how many moles of chromium? 1 mole. Okay, so like that, here take N1 and N2. So here what happened in this titration? The Fe plus 2 ions are converted into the Fe plus 3 ions. What is the reaction it is? Okay, is it oxidation reaction or reduction reaction? Iron 6 moles. And how many? ఇక్కడ ఏమవుతుందమ్మా? Fe plus 2 ions ఎలా మారిపోతున్నాయి? Fe plus 3 ions గా మారిపోతున్నాయి. అంటే ఏమవుతుంది అక్కడ? ఆక్సిడేషనా రిడక్షనా? ఆక్సిడేషన్. So if oxidation number increases, morning చెప్పుకున్నాం. Oxidation number increases, what is the reaction? Oxidation. Oxidation number decreases, reduction. Oxidation number decreases, reduction. Oxidation number increases, oxidation. So here, what is the oxidizing agent? K2Cr2O7. Cr2O7 is the oxidizing agent which oxidizes the Fe plus 2 ions into Fe plus 3 ions. So this is what redox reaction. Both oxidation and reduction reactions are takes place. And here it is what is the oxidation state of chromium here? What is the oxidizing? Chromium oxidation state ఎంత అవుతుంది? Cr2O7 is the oxidation. Can you find the oxidation number? How? What is the oxidation number of chromium in Cr2O7 minus 2? Redox reaction. Both oxidation and reduction reactions are takes place. And here, so Cr2O7 minus 2. What is the oxidation state of? So find the oxidation number of chromium. Plus 6. Can you find the oxidation number? Right? So how can you find? So you don't know the oxidation number of chromium. So let's say X. How many chromiums are there? 2. 2X plus. What is the oxidation number of normal oxygen? Minus 2. How many oxygens are there? How many oxygens are there? 7. So minus 2 into 7, minus 14 is equal to minus 2. Okay. And like that, how much it is? 2x plus 2x plus 2x minus what is the oxidation number of 17? Sir, 12 is equal to 0. X is equal to 12 by 2 and plus 6. So minus 2. Okay, here oxidation number of chromium is plus 6 and plus 6 to plus 3. Like that. And what happened? Here the oxidation number decreases. Oxidation number decreases so that it involves in reduction. And here oxidation number increases. It is a oxidation. So both oxidation and reduction reactions are takes place. That's why this titration is known as redox titration. Redox titration. And then what is the graph? Graph draw cheyali. So graph ela draw chestamo? So the graph is drawn between the x and that's why titration is known as redox. Okay, x and y axis. So this is y axis and this is x axis. Okay, on x axis take the volume of K2Cr2O7 and y axis we have to take the EMF values. EMF values. So the graph ela vastundi? Initially the EMF values are less and gradually the EMF values are increases on x axis and suddenly increases and then constant. Okay, so this point is known as end point. So the graph ela vastundi? Initially okay, this point is known as end point. So increases at particular volume, the EMF is suddenly increases. So next point ikkada. So sudden increase kabatti. So this point is treated as end point. Okay, so like that we can draw the graph of the potentiometric titrations. So this is about the redox titrations or potentiometric titrations. And next to clear kada? So sudden increase kabatti. Okay, so this point అయిపోయిందా? As end point. Okay, so like that we can draw the graph of the potentiometric titration. So this is about the redox titration. Next to and next to batteries. Okay, అయిపోయిందా? Okay, batteries. So what are batteries? Batteries are also known as cells. Batteries are also known as cells. Sometimes battery cell అని అంటాం. Okay, batteries ని కూడా cell అని అంటాం. Okay, so what are batteries? So batteries are the portable devices for the source of current. So batteries are the portable devices for the source of current. Okay, and in the batteries. Okay, so what are batteries? In the batteries, two or more than 2 or more than electrochemical cells. Electrochemical cells. Electrochemical cells are connected in the battery. 2 or more than electrochemical cells are connected seriously. Or more than 2 or more than. Okay. So in these batteries, generally in the batteries, the more than 2 or more than electrochemicals are connected seriously. Series లో కనెక్ట్ చేస్తాం. ఓకే, జనరల్ గా సెల్స్ అంటే one cell means contains 2 electrodes. Like that, how many cells are connected? 2 or more than. For example, in car battery, 6 electrochemical cells are connected seriously. 6 cells ని కనెక్ట్ చేస్తాం కార్ బ్యాటరీ. కార్ బ్యాటరీ తెలుసు కదా, కార్ బ్యాటరీలో ఏం యూజ్ చేస్తారు? లెడ్ యాసిడ్ బ్యాటరీ. కార్ బ్యాటరీలో లెడ్ యాసిడ్ బ్యాటరీ యూజ్ చేస్తాం. దానిలో ప్లస్ మైనస్ అట్లా 6 ఉంటాయి. మీరు అబ్జర్వ్ చేశారో లేదు? బ్యాటరీ అబ్జర్వ్ చేశారా? బాయ్స్ ఎక్కువ అబ్జర్వ్ చేస్తారు. కార్ బ్యాటరీ చూడండి, పాజిటివ్ పోల్ నెగిటివ్ పోల్, పాజిటివ్ పోల్ నెగిటివ్ పోల్, లైక్ దట్ 6 పాజిటివ్ పోల్స్, 6 నెగిటివ్ పోల్స్ ఉంటాయి. Okay, so in the batteries, 2 or more than electrochemical cells are connected seriously. Okay, and based on rechargeable capacity, based on rechargeable capacity, like that, rechargeable capacity cells, rechargeable capacity, these batteries are categorized into, classified into 2 types. Based on rechargeable capacity, these are 2 types. These are 2 types. Rechargeable capacity. Okay, how many types? 2 types. One is primary battery or primary cell. These batteries, primary cells. And the second one is secondary cells. Secondary cells are secondary battery. These are secondary cells are secondary battery. So what are primary cells? What are primary cells? One is primary cells అంటే ఏంటి? Primary cell. Primary cells. Primary. The second one is cells. Secondary cells. Secondary cells are secondary battery. The cells which are not rechargeable. The cells which are not rechargeable. The cells which are not rechargeable. Which are not rechargeable are called cells. Rechargeable are called primary cells. Are called primary cells. So the cells which are not rechargeable are called primary cells. And what are the examples? Not rechargeable. And some more points are there about primary cells. So these are single use cells. What are these? Single use cells. Primary cells. So these cells are working until the total battery is completed. After completion of the battery, we have to discard. అంతే కదా? So we have to discard. కాబట్టి these are single use cells. Single use cells are disposable cells. Disposable cells. వీటిని ఏమంటాం? These are disposable cells. Once used, the cells will be discarded. ఒకసారి యూజ్ చేసినామంటే సెల్స్ ను పడేయాల్సిందే బయట. కాబట్టి వాటిని ఏమంటారు? డిస్పోజబుల్. డిస్పోజబుల్ గ్లాసెస్ లాగా డిస్పోజబుల్ బ్యాటరీస్ అంటాం వీటిని. డిస్పోజబుల్ బ్యాటరీస్ ఆర్ సింగిల్ యూజ్ సెల్స్ అంటాం. అండ్ నెక్స్ట్, ఇన్ ద ప్రైమరీ సెల్స్, ద సెల్ రియాక్షన్స్ ఆర్ నాట్ రివర్సబుల్. Cell reactions are not reversible. Disposable glasses laga disposable batteries antaru. Disposable batteries are cell reactions are not reversible. Cell reactions are not reversible. Means only forward reaction takes place but not backward. Only forward reaction takes place but not backward reaction. So forward reaction మాత్రమే జరుగుతుంది. Forward reaction means only reactants are converted into products but not products are converted into reactants. Only reactants అనేది products లాగానే మారుతాయి. Only forward reaction మాత్రమే జరుగుతుంది. So those cells are called primary cells. And next examples. Forward reaction మాత్రమే జరుగుతుంది. Zinc air battery మనకు సిలబస్ లో ఉన్నది ఇది. Zinc air battery And lithium battery, lithium ion కాదు, lithium battery, lithium battery, lithium ion battery belongs to secondary cell, lithium battery. Okay, and Leclanche battery, Leclanche air battery మనకు సిలబస్ లో ఉన్నది ఇది, Leclanche battery and lithium battery. Okay, so on. Lithium ion కాదు, lithium battery. So these are what? Primary cells. What are primary cells? Belongs to secondary cell. What are primary cells? The cells which are not rechargeable are called primary cells. Recharge చేయలేని cells ని మనం అంటాం primary cells అంటాం. Okay, and what these are also called single use cells or disposable cells. And in these cells, the cell reactions are not reversible. Means only reactants are converted into products. Means only forward reaction takes place, but not backward. Okay, and example, zinc air battery, lithium battery, and Leclanche's battery. Okay, and next to secondary cells. Cell reactions are not reversible. Secondary cells. Only reactants are converted into products. Means only forward reaction takes place, but not backward. Okay, and example, zinc air battery, lithium. Second battery, one, secondary cells. Battery. Okay, and next to secondary cells. Secondary cells. What are secondary cells? ఏంటి? The cells which are rechargeable, are called secondary cells, secondary cells. What are secondary cells? Okay, and next point. So primary cells are single use cells, and these cells are multi-use cells. So these are what? Multi-use cells. Multi-use cells అంటాం. So number of times we can use these cells. Okay, because we can recharge. కాబట్టి we can use multi-use cells. And next to, so in the secondary cells, the cell reactions are reversible. The cell reactions are reversible. Means reactants are converted into products, and again the products are converted into reactants. So means forward reaction and backward reaction. Forward reaction జరుగుతుంది as well as backward reaction కూడా జరుగుతుంది. So కాబట్టి the cell reactions are reversible అంటాం. Cell reactions are reversible. Okay, and examples. Again, lithium ion battery, backward reaction. Okay, మనకున్నది ఒకటే బ్యాటరీ, lithium ion battery. And తర్వాత lead acid storage battery, reversible. Lead acid storage battery. Examples: lithium ion battery, nickel cadmium battery, like that. So many examples are there. So lithium ion battery. So lithium batteries, acid storage. What is the lithium battery storage? Lithium very important, lithium battery. Okay, and there zinc air battery. Okay, so this is about the secondary cells. And next to, we have some cells, and we have to know the structure ఓకే. ఇది ఈ ట్యాబ్ పోవట్లేదు. హలో. హలో. ఓకే అన్న. ఉండండి. ఓకే. Right. So at anode, zinc involves in the oxidation. Zinc involves in the oxidation in the presence of OH minus ions. In the presence of OH minus ions. Okay. So it involves in the oxidation by ZnO plus 2 electrons. Sorry. Plus H2O plus 2 electrons. Is it balanced? So how many oxygens? 2 oxygens, 2 hydrogens, right? So zinc oxide plus H2O, 2 electrons. Okay, this is what anodic reaction. So here, how can you know this zinc involves in oxidation? By knowing the oxidation numbers. So what is the oxidation number of zinc here? 0. What is the oxidation number of zinc here? Plus 2. Plus 2. 0 to plus 2 increases. So that oxidation reaction. So that oxidation reaction. So like that, zinc involves in oxidation. And next, at cathode. At cathode. At cathode, see, in the cathode, oxygen involves in the reduction reaction. Oxygen involves in the reduction reaction by in the presence of what? Water. It gains the electrons. It gains electrons and produces what? 2 OH minus ions. So balance ayindadi. Okay. Is it balanced? Of O2, H2O plus 2 electrons gives rise to 2 OH minus ions. Is it a reduction reaction, oxidation reaction? Is it oxidation or reduction? Why it is reduction? It gains the electrons. It gains the electrons. So that it is a reduction reaction. So this is what cathode reaction. So see the balancing equation. How many oxygens are there? After the reaction, 2. Before the reaction, half into 2. 1, 1, 2. How many hydrogens? 2 hydrogens. So like that, it is balanced. And next to write the cell reaction. Next to write the total cell reaction. So total cell reaction is Zn plus 2OH minus gives rise to ZnO plus H2O plus 2 electrons, right? And write the cathode reaction. What is that? Half O2 plus H2O plus 2 electrons gives rise to 2 OH minus. Okay, if any common, cut them. Okay, here 2 electrons get cancelled, and 2 OH minus ions, 2 OH minus ions get cancelled, and H2O get cancelled. And remaining Zn plus half O2 gives rise to ZnO. Gives rise to ZnO. So this is the total net reaction of the cell. Okay, ఈ battery యొక్క net reaction. And then applications where we use వేర్ వి యూజ్ దిస్ బ్యాటరీ అప్లికేషన్స్ ఎక్కడెక్కడ యూజ్ చేస్తాం జింక్ ఎయిర్ బ్యాటరీ ఎక్కడెక్కడ యూజ్ చేస్తాం రాయండి రియాక్షన్స్ సో అప్లికేషన్స్ సో దిస్ జింక్ ఎయిర్ బ్యాటరీ it is used in hearing devices hearing devices hearing devices hearing devices లో ఈ బ్యాటరీస్ ని యూజ్ చేస్తారు హియరింగ్ డివైజెస్ ఓకే హియరింగ్ డివైజెస్ లో ఈ బ్యాటరీస్ ని యూజ్ చేస్తారు అండ్ నెక్స్ట్ సో దీస్ ఆర్ used in used in pages pagers pagers what are pagers ఓల్డెన్ డేస్లో మొబైల్స్ రాకముందు పేజర్స్ ఉండేవి సో వాటిలో యూజ్ చేసేవాళ్ళు పేజర్స్ ఓల్డెన్ డేస్ అండ్ నెక్స్ట్ అండ్ దీస్ బ్యాటరీస్ ఆర్ ఆల్సో యూజ్డ్ ఇన్ ట్రాన్సిస్టర్స్ మిలిటరీ ట్రాన్సిస్టర్స్ ఓకే మిలిటరీ ట్రాన్సిస్టర్స్లో యూజ్ చేస్తారు సో దీస్ ఆర్ ది అప్లికేషన్స్ ఆఫ్ ది zinc air battery. So what is zinc air battery? Zinc air battery is a primary cell. Okay, we can't recharge this battery. Okay, and what is the composition? Anode is zinc and cathode is graphite. Which is covered by the Teflon cloth. And what is the electrolyte solution? KOH solution. Potassium hydroxide solution is used as an electrolytic solution. So this is the zinc air battery. And next రాశారు అందరు నెక్స్ట్ సెకండరీ right next secondary cell one of the secondary cell that is a lithium ion battery very important. So next to second one lithium ion battery. Lithium ion battery. What is lithium ion battery? So it is a secondary cell. It is a secondary cell means it is a rechargeable cell which is used in our mobiles లో యూజ్ చేసే బ్యాటరీ ఇదే దీని గురించి నేర్చుకోండి ఓకే మన మొబైల్లో యూజ్ చేసే బ్యాటరీ ఇదే రైట్ సో ఇట్ ఈస్ ఏ సెకండరీ సెల్ అండ్ నెక్స్ట్ in this lithium ion battery so the lithium ions are involved in intercalation what is the meaning of intercalation involved in intercalation means moving from anode to cathode and vice versa anode to cathode and vice versa cathode to anode. So that migration of or moving what moving of lithium ions, moving of lithium ions from anode to cathode, vice versa. So in this battery, the lithium ions are moving from anode to cathode, cathode to anode through the electrolytic solution, through the electrolyte solution. So that process is known as intercalation. 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 INTERCA. Intercalation. Okay, lithium ions are involved in intercalation, means moving of lithium ions from anode to cathode, vice versa. Okay, and then construction. Construction of the lithium ion battery. Construction of the lithium ion battery. See, anode is lithium graphite. Anode is lithium graphite, LiC6. LiC6. దాన్ని ఏమంటామంటే lithium graphite. Lithium graphite is anode. Lithium graphite is used as anode. And what is cathode? Cathode is lithium metal oxide. Lithium metal oxide. Lithium metal oxide is used as cathode. So here especially lithium cobalt oxide. Lithium generally frequently lithium cobalt oxide is used as cathode. And next to electrolytic solution. Electrolytic solution is lithium hexafluorophosphate. Hexafluorophosphate. Lithium hexafluorophosphate or lithium perchlorate. Lithium hexafluorophosphate. Lithium hexafluorophosphate is used as an electrolytic solution. లేదా lithium perchlorate. Lithium perchlorate. So this is the composition of the lithium ion battery. What is the anode? Anode is lithium graphite. Lithium graphite is the anode. What is the cathode? Lithium metal oxide. Lithium metal oxide. ఏంటది? Lithium cobalt oxide. Okay, lithium, another transition. We can take metal as a transition metal. Transition metal తీసుకోవచ్చు. Cobalt తీసుకోవచ్చు, manganese తీసుకోవచ్చు, ఇంకేదైనా తీసుకోవచ్చు. And electrolyte solution is lithium hexafluorophosphate. Lithium hexafluorophosphate. And then diagram. So diagram. ఏం చేద్దాం? So here the anode is taken as a thin plate like this, a thin sheet. Anode is like this. Okay, that is made by what? Lithium graphite. So this is made by the lithium graphite. Okay, ఈ విధంగా తీసుకుంటాం. And similarly cathode is also taken as a thin sheet, a thin plate. Okay, so this is what? Anode, sir, cathode. So that cathode is made up of what? Lithium cobalt oxide. Okay, and these two are separated by a separator. So these are separated by one separator like this. Okay, so these two electrodes are separated like this. Okay, and next to, and in between the these two electrodes, in between these two electrodes with Balaja. Okay, so between these two electrodes, one separator is there. Through the separator, okay, lithium ions are migrated from left to right, right to left, left to right, right to left. సో ఈ విధంగా లిథియం అయాన్స్ అనేటివి మైగ్రేట్ అవుతూ ఉంటాయి. ఓకే, సో and these two electrodes are connected to a battery like this, and this total arrangement is immersed in an electrolytic solution. What is that? ఏంటది? lithium hexafluorophosphate. Lithium hexafluorophosphate. Lithium hexafluorophosphate. So this is what? Lithium ion battery. So this is anode, and this one cathode, and this is separator, and this is what? Electrolytic solution. So this is the construction of the lithium ion battery. Okay, lithium ion battery construction ఈ విధంగా. Right, next working of the battery. See, during working, the redox reactions are takes place at respect to electrodes. Takes place at respect to electrodes. At respect to electrodes. So what are they? At anode, what is the anode? Lithium graphite. So LiC6 involves in the oxidation by loss of the lithium ion, and 1 electron, and C6. Okay, 1 electron. And next to cathode reaction. At cathode, see, cobalt oxide involves in the reduction reaction in the presence of lithium ion, gain 1 electron, and produces lithium cobalt oxide. So cobalt oxide involves in the reduction in the presence of lithium ion. Produces lithium cobalt oxide. This is what? Reduction reaction. And write the net reaction. Okay, so net reaction or cell reaction రాయాలి. ఎలా రాస్తాము? lithium C6 Li plus 1 electron plus C6, and cathode reaction cobalt oxide plus lithium plus 1 electron gives rise to lithium cobalt oxide. So common ఏమైనా ఉంటే కట్ చేయండి. 1 electron, lithium ion get cancel, and remaining ఏముంది? lithium C6 cobalt oxide gives rise to lithium cobalt oxide and C6. So this is the net reaction of the cell. Right. Okay. And then applications where we use applications of the lithium ion battery. So this lithium ion battery, it is used in aircrafts, 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 aircrafts లో యూజ్ చేస్తాం, ఎస్పెషల్లీ aircrafts to make Boeing Boeing 787 Boeing 787 అబ్దుల్ కలాం దానిలో ట్రావెల్ చేశారు ఆ స్పేస్ ఆ ఎయిర్క్రాఫ్ట్ లో అబ్దుల్ కలాం ఎవరు ఎక్స్ ప్రెసిడెంట్ అతను దానిలో ట్రావెల్ చేశారు బోయింగ్ 787. ఓకే, టు మేక్ బోయింగ్ 787. సో ఇన్ దట్ ఎయిర్క్రాఫ్ట్స్ దీస్ బ్యాటరీస్ ఆర్ యూస్డ్. ఈ బ్యాటరీస్ని మనం యూజ్ చేస్తాం. అండ్ ఆల్సో యూజ్డ్ ఇన్ electronic household electronic devices, household electronic devices, used in household electronic devices. అంటే so nowadays the mobiles are household article. Is it a household article? మొబైల్స్ అనేది ఇంట్లో వాడే నెసెసరీ ఐటమ్ అయిపోయింది కాబట్టి దాన్ని కామన్గా చెప్పేసినాం. అలా ఏంటి హౌస్ హోల్డ్ ఆర్టికల్, ఎలక్ట్రానిక్ డివైజెస్, హౌస్ హోల్డ్ ఎలక్ట్రానిక్ డివైజెస్, నాట్ ఓన్లీ మొబైల్స్, ఇంకా వేరెవర్ యూస్ వీ కెన్ యూస్ దట్ లిథియం అయాన్ బ్యాటరీ. ఓకే, సో హౌస్ హోల్డ్ ఎలక్ట్రానిక్ డివైజెస్లో ఈ లిథియం అయాన్ బ్యాటరీస్ను యూజ్ చేస్తాం. సో దిస్ ఇస్ అబౌట్ ది సెకండరీ సెల్స్. ఈజ్ ఇట్ క్లియర్? ఓకేనా? అండ్ నెక్స్ట్ మనకు ప్రైమరీ సెల్లో ఒక ఎగ్జాంపుల్ అయిపోయింది, సెకండరీ సెల్లో ఒక ఎగ్జాంపుల్ అయిపోయింది. అండ్ నెక్స్ట్ ఫ్యూయల్ సెల్స్ నెక్స్ట్ ఉన్నాయండి. ఫ్యూయల్ సెల్స్ నోట్ చేసుకోండి అవి. సో వాట్ ఆర్ ఫ్యూయల్ సెల్స్? అయిపోయిందా? నెక్స్ట్ ఫ్యూయల్ సెల్స్. What are fuel cells? So fuel cells are, these are an electrochemical cells. These are an electrochemical cells. Fuel cells are an electrochemical cells which converts chemical energy in the form of fuel, converted into electricity, Okay, so these fuel cells are also convert the chemical energy into electrical energy, but here the chemical energy is provided by the fuel. Fuel తో మనము కెమికల్ ఎనర్జీని ప్రొవైడ్ చేస్తాం. ఓకే, కెమికల్ ఎనర్జీ is provided by the in the form of fuel and that is converted into electricity, so known as fuel cells. And in the fuel cells we have two fuel cells. One is hydrogen oxygen fuel cell, and next to proton membrane electrolyte fuel cell. Okay, proton membrane electrolyte fuel cell. So first hydrogen oxygen fuel cell చూద్దాం. Hydrogen oxygen fuel cell. So what is hydrogen oxygen fuel cell? It is an electrochemical cell. It is an electrochemical cell. It is an electrochemical cell. Okay, that is the first point. And then construction of the fuel cell. So construction lo em chestamu? Anode. What is anode? What is anode? Porous graphite rod. Porous graphite rod. Porous graphite rod which is coated by platinum. Which is coated by platinum. Porous graphite rod which is coated by the platinum. And similarly, cathode. So what is cathode? Also same. Porous graphite rod. Porous graphite rod which is coated by same platinum. Okay, it is also coated by the platinum. And next to electrolytic solution. Electrolytic solution. So here electrolyte solution is potassium hydroxide solution. Electrolyte solution is potassium hydroxide solution. So then draw the diagram draw చేద్దాం. సో మనం ప్రతి సెల్ని కూడా ఇలాగ కన్స్ట్రక్ట్ చేసుకుంటూ వస్తున్నాం. ఓకే, యానోడ్ ఏంటి, క్యాథోడ్ ఏంటి, ఎలక్ట్రోలైట్ సొల్యూషన్ ఏంటి. వాట్ ఈజ్ యానోడ్, క్యాథోడ్ అండ్ ఎలక్ట్రోలైటిక్ సొల్యూషన్. సో హియర్ యానోడ్ ఈజ్, వాట్ ఈజ్ యానోడ్? porous graphite rod. Porous graphite rod. It has pores like this. It has small holes. Porous graphite rod. And what is cathode? Cathode also a porous graphite rod. It also has pores. Okay, and here this rod has one arrangement to enter the gases and exit the gases. To enter and exit the gases, one arrangement is there like this. So through this inlet, hydrogen gas is entered into the graphite rod, and here also it has same. So the facility is like this, and through this oxygen gas is entered. Oxygen gas is entered into this graphite rod. So in between these two electrodes, the potassium hydroxide solution is there. Okay, so this is the arrangement of the electrode. This is the arrangement of the cell. Hydrogen oxygen fuel cell. See, ఇక్కడ ఏం చేస్తున్నాం చూడండి. Here this is the anode, and through the anode we are bubbling the hydrogen gas. And through the cathode we are bubbling oxygen gas. Okay, anode ద్వారేమో హైడ్రోజన్ గ్యాస్ ని బబ్లింగ్ చేస్తున్నాం, క్యాథోడ్ ద్వారానేమో ఆక్సిజన్ గ్యాస్ ని బబ్లింగ్ చేస్తున్నాం. And in between these two electrodes, potassium hydroxide solution is taken as an electrolytic solution. Okay, potassium hydroxide solution nu electrolyte solution laga తీసుకున్నాం. Okay, this is the construction. And then working of the fuel cell. How it works? And during working, what happened? ఏం జరుగుతుంది డ్యూరింగ్ వర్కింగ్? ఇప్పటికీ ఇది 5th సెల్. ఓకే, 5th సెల్ చెప్తున్నాం. ఏమవుతుంది డ్యూరింగ్ వర్కింగ్ ఆఫ్ ది డ్యూరింగ్ వర్కింగ్ the redox reactions are takes place at a respective electrode. So at anode, what is the anode? Graphite rod, but that graphite rod not involves in the reaction. Which is involves? Hydrogen involves in the oxidation. So in the presence of OH minus ions, it involves in the oxidation by loss of what happened? Hydrogen gas involves in the okay. So H2 in the presence of OH minus ions involves in the oxidation by loss of the electrons. By loss of how many electrons? 2 electrons. By loss of 2 electrons, it involves in the oxidation reaction. And this is what anodic reaction. And next at cathode. What is the cathode? Graphite rod only. So on the cathode, we are bubbling the oxygen gas. We are bubbling what? Oxygen gas. That oxygen gas involves in the oxidation reaction. So that oxygen gas involves in the oxidation reaction in the presence of water molecule and gains electrons and gives rise to OH minus ion. How many OH minus ions? Okay, half O2 plus H2O and involves in the reduction reaction and produces what? 2 OH minus ions. And write the net reaction. Or cell reaction. Cell reaction. So cell reaction is cell reaction. Okay, H2 plus 2 OH minus ion gives rise to 2 H2O plus 2 electrons. And next to half O2 plus H2O plus 2 electrons gives rise to 2 OH minus ions. Okay, right. So ఏమైనా కామన్ ఉన్నాయా? ఏమైనా కామన్ అంటే 2 electrons get cancelled and OH minus ion get cancelled, and here one water molecule, and from this one water molecule and one water molecule remains. Okay, so write the net reaction. H2 plus half O2 gives rise to H2O gives rise to H2O. ఇక్కడ ఒక వాటర్ మాలిక్యూల్ మిగిలిపోయింది కదా. Okay, H2O. This is what? Net reaction of the cell. Okay, and then applications. Where we use these batteries. So next applications used in aircrafts, space vehicles, and space vehicles and military applications. So what is the final product in the fuel cell? What is the product in the fuel cell? Water. So this water is comes out from this outlet. This water is comes out from this outlet. Water is comes out from that outlet. So ఈ అవుట్లెట్ నుంచి ఈ అవుట్లెట్ ఏమొస్తుంది వాటర్ వస్తుంది కాబట్టి సో this battery is also used for drinking water for astronauts సునీత విలియమ్స్ చూసారు కదా సునీత విలియమ్స్ ఆమె వాటరు అందులో ఆ బ్యాటరీ ద్వారా వచ్చే వాటర్నే తాగేదనమాట ఓకే సో ఈ ఫ్యూయల్ సెల్స్లో ఏమొస్తుంది వాటర్ కూడా ప్రొడ్యూస్ అవుతుంది సో దట్ వాటర్ ఈజ్ యూజ్డ్ యాజ్ ఎ డ్రింకింగ్ వాటర్ ఫర్ ద ఆస్ట్రోనాట్స్ వాట్ ఆర్ ఆస్ట్రోనాట్స్ astronauts means who travels in the space vehicles ఓకే స్పేస్లో ట్రావెల్ చేసే వాళ్ళని ఆస్ట్రోనాట్స్ అంటాం వాళ్ళకి డ్రింకింగ్ వాటర్ లాగా ఈ బ్యాటరీ యూజ్ అవుతుంది ఓకే యాజ్ వెల్ యాజ్ ఎలక్ట్రికల్ ఎనర్జీ సోర్సెస్ లాగా కాకుండా డ్రింకింగ్ వాటర్ లాగా కూడా యూజ్ అవుతుంది ఎందుకంటే హియర్ ద ప్రొడక్ట్ ఈస్ వాటర్ సో ఈ ఫ్యూయల్ సెల్లో వర్కింగ్లో మనకి ఏం ప్రొడ్యూస్ అవుతుంది వాటర్ ప్రొడ్యూస్ అవుతుంది కాబట్టి సో ఈ సెల్ని డ్రింకింగ్ వాటర్ పర్పస్లో కూడా యూజ్ చేస్తారు డ్రింకింగ్ వాటర్ for astronauts used as drinking water for astronauts okay next fuel cell so last fuel cell second one proton membrane exchange fuel cell so dine PMFEFC proton membrane exchange fuel cell and it is also called polymer electrolyte fuel cell okay and what is this so it is an electrochemical cell it is an electrochemical cell means it converts chemical energy into electrical energy but here the chemical energy can be supplied in the form of fuel form lo supply chestam and then construction of the cell so what is anode is platinum rod is used as anode and cathode also used as platinum rod only porous okay and electrolytic solution perfluoro perfluorosulfonic acid. Perfluorosulfonic acid is the electrolyte solution. It is a one of the polymer. So that is in the form of membrane. That is in the form of membrane. Membrane form lo ఉంటుంది. Okay. Perfluorosulfonic acid. Perfluorosulfonic acid. Perfluorosulfonic acid. Perfluorosulfonic acid. Perfluorosulfonic acid. Right. So next to construction. The diagram. So diagram is same hydrogen oxygen fuel cell laga, and this is platinum electrode, and this is also platinum electrode, and here one one arrangement is there, and through that arrangement the fuels are entered into the electrode. The fuels are entered into the electrode. Okay, and these two electrodes are separated by a membrane. This is polymer membrane, proton membrane. Okay, proton membrane. So in this H plus ions are migrated from one electrode to another electrode, and these two electrodes are connected through a battery like this. Right? And through this, here we are bubbling the hydrogen gas, and here through this oxygen gas, and here the fuel అంటే ఇక్కడ హైడ్రోజన్ గ్యాస్ ని బబ్లింగ్ చేస్తాం, and also we can use hydrocarbons in the place of hydrogen. We can use hydrocarbons are also used as fuels. Okay, and then working of this cell, proton membrane exchange fuel cell. Proton membrane exchange fuel cell. Proton exchange membrane fuel cell. Proton exchange, not membrane exchange. చిన్న కరెక్షన్ ఒకటి. ప్రోటాన్ ఎక్స్చేంజ్ ఇక్కడ రాయండి, ఎక్స్చేంజ్ ఇక్కడ వస్తుంది. ఎక్స్చేంజ్ membrane fuel cell. Proton exchange membrane, and it is also called polymer electrolyte membrane fuel cell. ఇక్కడ కూడా చేంజ్ అవుతుంది. Proton exchange membrane fuel cell. Proton exchange membrane fuel cell or polymer electrolyte membrane fuel cell. Right. See, at anode, same during the reaction, during the working of this fuel cell, what reactions are takes place? Redox reactions are takes place. So oxidation reaction at anode and reduction reaction at cathode. సో అదే రాయాలి. ఎట్ యానోడ్, హియర్ ద యానోడ్ hydrogen gas involves in the oxidation by loss of electrons, by loss of 2 electrons. Okay, by loss of 2 electrons, that hydrogen gas involves in the oxidation. And next to at cathode, at cathode ఇక్కడ ఏమవుతుంది చూడండి. సో యానోడ్ లిబరేట్స్ వాట్, యానోడ్ లిబరేట్ ది ప్రోటాన్స్ అండ్ దీస్ ప్రోటాన్స్ ఆర్ మైగ్రేటెడ్ టువర్డ్స్ ది క్యాథోడ్, క్యాథోడ్ వైపు మైగ్రేట్ అవుతాయి. సో దిస్ ఈజ్ వాట్ క్యాథోడ్. అందుకోసమే ఏం చేసినాం, ఇక్కడ ప్రోటాన్స్ తీసుకున్నాం, మిడిల్లో ప్రోటాన్స్ తీసుకున్నాం. దీస్ ప్రోటాన్స్ ఆర్ మైగ్రేటెడ్ ఫ్రమ్ యానోడ్ టు క్యాథోడ్. ఓకే, యానోడ్ నుంచి క్యాథోడ్కి ఈ ప్రోటాన్స్ అనేటివి మైగ్రేట్ అవుతున్నాయి. అండ్ దెన్ డ్యూరింగ్ క్యాథోడిక్ రియాక్షన్ ఏమవుతుంది, ఇక్కడ ఆక్సిజన్ ఇన్వాల్వ్స్ ఇన్ reduction reaction by gain of electrons, by gain of electrons ఏమవుతుంది, by gain of electrons this oxygen involves in the reduction reaction in the presence of protons, in the presence of protons. Okay, like that anodic and cathodic reactions are takes place. And then total reaction, that is cell reaction. Cell reaction, H2 gives rise to 2H plus 2 electrons, and then half O2 plus 2H plus 2 electrons gives rise to H2O. Okay, 2 electrons get cancelled, 2H plus get cancelled, and H2 plus half O2 gives rise to H2O. H2 plus half O2 gives rise to H2O. So this is what and next applications. So where we use so these proton electrolyte, polymer electrolyte membrane fuel cells are used in buses and cars. బస్సులో కూడా వీటిని యూజ్ చేస్తారు, ప్రోటాన్ ఎలక్ట్రోలైట్ మెంబ్రేన్ ఫ్యూయల్ సెల్. అండ్ నెక్స్ట్ ఇన్ పోర్టబుల్ డివైజెస్ లో కూడా యూజ్ చేస్తారు. అండ్ నెక్స్ట్ యూజ్డ్ ఇన్ స్పేస్ అండ్ మిలిటరీ అప్లికేషన్స్, లో యూజ్ చేస్తారు. ఎందుకంటే ఎనర్జీతో పాటుగా వాటర్ కూడా ప్రొడ్యూస్ అవుతుంది కాబట్టి స్పేస్ అండ్ మిలిటరీ అప్లికేషన్స్లో వీటిని యూజ్ చేస్తారు. ఓకే, సో దిస్ ఇస్ అబౌట్ ది ప్రోటాన్ ఎక్స్చేంజ్ మెంబ్రేన్ ఫ్యూయల్ సెల్. ఓకే, అండ్ వన్ టాపిక్ ఈజ్ రిమైన్స్, ఇంకొక టాపిక్ ఉంది, ఏంటది, ఎలక్ట్రోకెమికల్ సెన్సార్స్. చెప్పుకుందాం, ఎలక్ట్రోకెమికల్ సెన్సార్స్ అదొకటి అయిపోతే టోటల్ యూనిట్ అనేది కంప్లీట్ అవుతుంది. ఓకే, తొందరనే అయిపోతుంది, ఒక హాఫ్ అన్ అవర్లో అయిపోతుంది. ఓకేనా, మీరు రెడీయా? మీరు రెడీ అయితే నేను రెడీ. రైట్. ఎలక్ట్రోకెమికల్ సెన్సార్స్. Electrochemical sensors. What are electrochemical sensors? What are electrochemical sensors? So these are the devices. These are devices which converts chemical energy into suitable electrical signals. Electrical signals. Electrical signals to the computers, to the computer. So are called sensors, electrochemical sensors. So electrochemical cells ante enti? Electrochemical cells are the devices which converts chemical energy into electrical energy అంటున్నాం కదా. ఇక్కడ కూడా సేమ్ మీనింగ్ వస్తుంది చూడండి. These are the devices which converts chemical energy into suitable electrical signals. Suitable electrical signals to the computer is known as electrochemical sensors. Electrochemical sensors. And these electrochemical sensors are three types. These are three types. One is potentiometric sensors. Potentiometric sensors. And second one is amperometric sensor. Amperometric sensors. And third one is conductometric sensors. Conductometric sensors. Okay, potentiometric sensors, amperometric sensors, and conductometric sensors. So what are potentiometric sensors? Potentiometric sensors are the devices which measure the potential of the solution, potential of the test solution. Okay, test solution యొక్క పొటెన్షియల్ ను మెజర్ చేస్తాయి. అండ్ వాట్ అబౌట్ ఆంపియరోమెట్రిక్ సెన్సార్స్? ఆ పేరులోనే ఉంది, ఆంపియర్ మీన్స్ కరెంట్. సో మెజర్స్ వాట్? కరెంట్ ఆఫ్ ది టెస్ట్ సొల్యూషన్. ఓకే, అండ్ వాట్ అబౌట్ కండక్టోమెట్రిక్ సెన్సార్స్? కండక్టెన్స్ ఆఫ్ ది test solution. Okay, and in this we have only two sensors. One is potentiometric sensors and second one is the amperometric sensors. ఈ రెండు చెప్పుకుంటే ఈ చాప్టర్ అయిపోతుంది, యూనిట్ అయిపోతుంది. ఓకే, what are they? Potentiometric sensors and amperometric sensors. ఫస్ట్ potentiometric sensor చూద్దాం. Potentiometric sensors. Potentiometric sensors. So these are the devices. These are devices which measures the potential difference between working electrode and reference electrode. Okay, what are potentiometric sensors? These are devices which measures the potential difference between the working electrode and reference electrode. So in this we are using two electrodes. One is reference electrode and second one is the Second one is the working electrode and reference electrode. Working electrode and reference electrode. And then working electrode is a ion selective electrode. Is a ion selective electrode. It is a ion selective electrode. Ion selective electrode. And working electrode is also known as working electrode is also known as glass electrode. Glass electrode అని కూడా అంటాం దీన్ని. Working electrode is also known as glass. What is working electrode? It is ion selective electrode, means so it has the sensor. It has the sensor which responds to the specific ions. It responds to the specific ions, means H plus ions. It responds to only H plus ions and ignore the remaining ions. Only that ion selective electrode. Working electrode is a ion selective electrode antunnam kada. So it responds to only H plus ions in the test solution. Test solution lo unde H plus ions మాత్రమే respond అవుతుంది. Okay, and working electrode is also known as glass electrode. Glass electrode అని కూడా అంటాం. అండ్ దీని యొక్క వర్క్ ఎలా ఉంటుందో చూద్దాం. ఎక్కడెక్కడ యూజ్ చేస్తాం అండ్ ఎలా ఉంటుందో చూద్దాం. రైట్, సి the potential of the working electrode varies with the concentration of H plus ions. Okay, so working electrode is a ion selective electrode, means it responds to only H plus ions. And that working electrode potential, the potential of the working electrode varies with the concentration of the H plus ions. If the concentration of H plus ions increases, the potential of that electrode also varies. Okay, so varies with the concentration of the H plus ions. Okay, and then construction ఎలా ఉంటుందో చూద్దాం. Construction, see this potentiometric sensors has two electrodes. One is working electrode and another one is the reference electrode. And these two electrodes are connected to a device. So what is this? This is the device. It may be computer, whatever it is. Okay, these two electrodes are connected to the device, right? And these two electrodes are dipped in the test solution. ఈ టెస్ట్ సొల్యూషన్ లో డిప్ చేస్తాం. టెస్ట్ సొల్యూషన్. Okay, and see this working electrode has a bubble at the end. So this is the bubble, and that is made by the particular glass, and that glass responds to the specific ions like H plus ions. So ఈ బల్బ్ ఏదైతే